So let's see the question number 1. Identify and describe 3 stages of program development life cycle. So we know there are 4 stages of program development life cycle. Okay, the first stage is called the analysis stage. In this stage, we understand what the program needs to do by gathering the requirements. Okay. Next stage is called the design stage. In this stage, planning how the program will work and look before building it. Okay, and we use the structure diagram and flowchart and pseudocode, all those things in this stage. Third stage is called the coding stage. So writing the actual instruction of the code that the computer will follow. So in this stage, we write the code for the program using some programming language, let's say Python, C# or any other programming language. Last stage is called the testing stage. In this stage, we check the program for the errors to make sure it works correctly. Okay. Question number 2, take one box to show which task is part of analysis stage of the program development life cycle. So option A is testing, option B is coding, option C is decomposition, and option D is design. So as we know that testing, coding, and design, these are the 3 stages of program development life cycle. They are not sub-tasks of the any of the stage. So the correct answer would be C, decomposition. Decomposition is what is a subtask as a part of analysis stage. Okay. Question number 3. 4 description of stages in the program development life cycles are shown. Draw one line to link each description to its most appropriate program development lifecycle stage. Not all program development lifecycle stages will be used. So here you can see you have different name of the stage of program development lifecycle. For example, analysis stage, coding stage, design stage, evaluation, and testing. And here we have the statement. So statement number 1 is develop an algorithm to solve the problem by using structure diagram, flowchart, and pseudocode. So that's the design stage. Okay. Next one is detect and fix the errors in the program. That's the testing stage. Identify the problem and its requirements. That's the analysis stage. Write and implement the instruction to solve the problem. So that is the coding stage. Okay. Let's see the question number 3. Question number 4. Identify 3 different tasks in the analysis stage of the program development life cycle. So we have 3 tasks. Number 1 is gather the requirements. Number 2, analyze the user's need. Number 3 is define the system specification. Question number 5, abstraction, decomposition, and structure diagrams are tools used during the program development life cycle. Identify the stage of program development life cycle where they are used and describe what they are used for. Okay, so let's talk about the first one. First is abstraction. So it is used in analysis stage. So what is abstraction? The process of simplifying complex system by focusing on the essential features and ignoring the unnecessary details. Okay. Next one is decomposition. It's also used in analysis stage. So what is decomposition? Is breaking down a complex problem or system into smaller, more manageable sub-problems or components. Third one is structure diagram. Structure diagram is used in design stage. So what is structure diagram? So visual representation that illustrate the organization and relationship of different components within a system or a program. Okay. Question number 6, state 3 of the component part of a computer system. So there are 4 main component part of a computer system. Number 1 is input, number 2 is process, number 3 output, and number 4 is storage. Question number 7, draw a flowchart to convert the length in feet to centimeter, and the formula is what? Length in feet multiplied by 30. So how do we start the flowchart? First of all, we draw this shape, okay? This shape to start the flowchart. Next, we have to do what? We have to ask a user to input the length in feet. So this shape is used to ask a user to input the data, okay? Then we need to do what? We need to multiply the length in feet and with the 30, number 30, okay? So here we can see we use this shape. Rectangle shape is used to show the process because it's the process, right? Length in feet multiplied by 30, and we will get the length in centimeters and we'll store it in the variable LCM. The next is we need to output that one, right? So which shape we use for the output? We use the same shape as the input for the output. So that's, here we go. We output the LCM and then we can close the flowchart with the same shape. So as you can see here, 2 things. The first start and the stop shapes are same. Next, input and output shapes are same. And the rectangle shape is used to show the process. Okay. Let's see question number 8. Draw a flowchart to add 2 numbers entered by the user. So now you need to ask the user 2 numbers and add them together and then output the sum. Okay. So same thing, we start the flowchart with this shape, then we ask a user to input the number 1 and number 2, and then we can add the numbers together and store the result in a variable called the total, and then we need to output the result. Okay, output is equal to total. Okay, output total, sorry. And then we can simply close the flowchart. Question number 9, draw a flowchart to read two numerical values, determine the largest of the two values and output the largest value. So this time we have to use the if statement, right? So let's see which statement, which symbol we can use to represent the if statement. So same thing, we start the program. Okay, we ask the user to input two values, value 1 and value 2, and then we need to do what? We need to make a decision. So for the decision, we use this shape. This shape is the diamond shape, okay? So here we write the what we need to comparison. So is value 1 greater than value 2? Okay, if yes, okay, if yes, we do what? We make the variable max, set the variable max to value 1, or if no, then we set the variable max to value 2. And finally, we output the value max, and we can simply close the flowchart with the stop shape symbol or shape. Okay, so here you can see we use this symbol to do what? To do the comparison. Okay, and it has two possible answers, yes and no. Okay. Question number 10, draw a flowchart to represent an algorithm that reads a number and identifies whether the number is positive or negative. You should use standard flowchart symbols. Okay, so now this time we need to find if a number is positive or a negative. So a number, any number that is below 0 is considered as a negative number. Any number above 0 is considered as positive number. Okay. So same thing, we start the flowchart with the start symbol, then we ask a user to input a number, and then we need to check if the number is less than 0. So is number less than 0? If it's true, we output what? We output the number is negative. If it's false, we output what? We output the number, the positive, the word positive, okay? And at the end, we can just simply stop the program. Okay, question number 11, develop a flowchart based on the provided code. So this time we have a code. You need to draw a flowchart based on the code. So same thing, we start the flowchart with the start symbol. Then the first statement is score equal to 75. So it's a process because we are assigning the value 75 to the variable score, right? So we use a rectangle shape here, okay? Score equals to 75, not 5, okay? And then we check the, we need to check this condition. If score greater than 50, so we use the diamond shape. So is score greater than 50? If it's true, then we output the message passed. And if it's false, we do nothing, okay? So if it's yes, then we do what? We output passed, this message. And if it's no, we do what? We do nothing. And finally, we can stop the program. Okay, question number 12, develop a flowchart based on the provided code. So this time we have a code, same thing. We start the flowchart. Okay, then we ask the user, we store the number 60 to the variable mark. So it's a process. Then we again check if mark is greater than 50. So same, we have a decision here. Is mark greater than 50? If it's yes, we output the message passed. Okay, and if it's no or else we output the message what? Failed. And that's it. That's how you use the if and else using the flowchart. Let's see another example. Develop a flowchart based on the provided code. And let's see, now you have if, else, if, okay, statements and else. So let's see how we draw the flowchart for this program. So same thing, we can start the program and we store the 60 to the variable mark. And then we check the first condition, if mark is greater than 80. Okay, if it's true, we output the message mark A. And if it's no, then we need to check, we need to add another diamond shape to check this condition. Okay, so no, and in the case of no, we ask is mark is greater than 60. Okay, so if it's true, we output the message mark C. If it's no, we output the message failed in the else. Okay, and then we can simply close the flowchart. Question number 14, the following 4 pseudocode statements and 3 flowchart symbols are shown. Draw a line from each pseudocode to the shape. Okay, so first one is what? If x greater than 12. So which shape we can use to represent this one? This is the if else, right? So we need to use this shape or symbol. It's a diamond symbol for the if statement. Next one is input x. So which shape we use for the input? So it's the shape number, this shape. Okay. Then x equals to y plus c. So that's the process. We're adding two numbers and assigning the result of those two values to the variable x. So that's we use the first symbol, a rectangle symbol. Then output equals to x. So output is what? Output is also this shape. So input and output, we use this shape. Okay. Question 15, what is the purpose of the following shape in the flowchart? So this shape is what? Let's see, the option A represent a subroutine, option B represent a decision, option C represent an input output, and option D represent a terminator. So it's not terminator, it's not used to represent input and output, it's not represented to represent a decision. So the correct answer is option A, it represents a subroutine. Question 16, draw the most appropriate flowchart symbol for each pseudocode statement. So the first statement is if number equal to 20, so which shape is most appropriate? Is a diamond shape, okay? Next one, if a number equals to number plus 1, so this is a process, we use the rectangle shape. Okay, so here is the rectangle, this is a mistake here, okay? Next one is the print. Print is what? Print is this shape. So for the print, we use this shape, and for the number equal to number plus 1, we use this shape. Here is just a mistake, okay? Question 17, describe the purpose of flow lines in the flow chart. So what is the purpose of flow line in the flow chart? The flow lines it uses the arrows to show the direction of the flow through the chart, which is usually, but not always, top to bottom and left to right, okay? Question 18, an array called student is used to store the names of 20 students. The array is indexed from 0 to 19. So it is students 0 to 19. The names of the students need to be output using a loop. There are different types of loops that can be used. A precondition loops test the loop condition at the start of each iteration. Draw a flowchart to show how a precondition loop can be used to output the names of all the students. So here we can see, so same thing, you start the flowchart and then we set the counter to 0, and then is counter is greater than 19. If this condition is what? False, then we, if this condition is true, okay, or counter is less than what? 19 is no, then we can do what? We can output a statement. So student counter. So student is the name of array, and counter, the value of the counter is what? 0. So it will output the first element from the student array. And then we need to increment the counter by 1. So counter equal to counter plus 1, which means add 1 to the value of counter. The value of counter is 0. So 0 plus 1 will become 1. And then since we are in the loop, we go back, okay? And we will run those lines of code until the value of counter it becomes greater than 19. Okay. So once it becomes greater than 19, we can simply stop the program. And that's how you create the flowchart of the precondition loop. Question number 19, the same question, but this time we have to draw a flowchart to show how a post-condition loop can be used to output the names of all. So this time we have to use the post-condition loop. So post-condition loop is called the repeat until loop, right? So pre-condition loop is called the while loop. So let's see how we can draw a flowchart using the repeat until loop. So same thing, we can start the flowchart, and then we we set the counter to 0, and then we output the first element from the counter, yes, the array student, and then we increment the counter by 1, and then we have a decision here, right? Because in the repeat until loop, the condition is tested at the end. So we check if the condition is true or false. So if it's not no, then we go back. Okay, it's not satisfied, we go back, and we repeat those lines of code until the value of counter is greater than 19. So once it becomes greater than 19, we can simply stop the program. Okay. Question 20, a program asks the user to enter 2 numbers. The program then adds the number together and output the total. Draw a structure diagram of the program. So now we need to draw a structure diagram for the program. So let's see how you draw the structure diagram. So for drawing the structure diagrams, first step is you need to write the program name at the top. Okay, so for example, this program name is what? Addition. So it's adding 2 numbers. Then you need to divide this thing into 3 things. First one is inputs. What are the inputs? What are the processes? And what is the output? Okay, so let's find out what are the inputs. So in this question, you can see ask a user to input 2 numbers. So it means we have to ask a user 2 numbers, number 1 and number 2. So these are our 2 inputs. Then the program adds the numbers together. So that's the process, right? Add number 1 plus number 2 and store the result of those 2 numbers in a variable total. And then output the total. So we need to output the total. That's our output. So we just simply write the total under the output. Okay. So remember, whenever you have to draw a structure diagram, first of all, you need to write the program at the top. Then you need to divide it to input, process, and output. And then you can just simply add the inputs and process and total underneath those headings. Okay. Question 21, a satellite navigation system need to ask the user to input their destination. It then finds the route to the destination and output and outputs the instruction to the user. Draw the structure diagram for the system. So same thing, we write the programming, let's say satellite navigation system, we just make it short, sat nav. And then we just divide the program into three things. So what are the inputs? What is the process? Okay, and what is the output? What are the inputs? So the input is destination. So user will input the destination address. Okay, what is the process? The process is the program will find the route. And what is the output? So output is what the app will show the directions of the from the user location to the destination. Okay, question 22. A login system is required. The system asks the user to enter their username and password. It checks if these are valid. If they are correct, the system outputs that they are correct. If they are incorrect, the system outputs that they are incorrect and prompts the user to re-enter their username and passwords. Draw a structure diagram for this login system. So that's the same thing. We need to write the program name at the top. Then we divide the program into inputs, processes, and the output. Okay. Then we need to find the inputs. So what are the inputs? The first input is the user will need to input the username and the password. And then what is the process? There are two processes. First one is finding the username and the password in the database, and then comparing the username and the password with the stored value. And finally, output two messages. If the password is correct, it will show a message correct. If it's incorrect, then it will output the message incorrect and also ask the user to re-enter. Okay. Okay, next question number 23. Take one box in each row to identify if the statement about structure diagram is true or false. Okay, so first statement is what a structure diagram is a piece of code that is available through the structured up program. So that is false. It's not a piece of code. A structure diagram shows the hierarchy of a system. That's true. A structure diagram is another name of an array. That's false. A structure diagram shows the relationship between different components of a system. That's true. Question 24, identify 4 types of test data used in the software testing. So we know there are 4 types of test data. For example, first one is the normal data, abnormal data, extreme data, and the boundary data. So what is normal data? Data that the program should accept is called the normal data. And then abnormal data that the program should not accept is called the abnormal data. Then you have extreme data that is at the edge of what is allowed. And boundary data is what the data that is on the edge of being accepted and being rejected. So these are the 4 types of test data. Okay, question number 25. A program allowed the user to enter 5 numbers between 1 to 5. Find normal, abnormal, boundary, and extreme input values for the program. Okay, so as we know, the program only accepts numbers from 1 to 5. So this number, any number between 1 and 5 is our normal data. And anything outside of this range is the abnormal value. Okay. Next, let's see what is the extreme value. So extreme value is what? 1 minimum value and maximum value 5. So these are the 2 numbers are our extreme data. Now let's see what is the boundary data. For the boundary data, you can say minimum number minus 1 and maximum number plus 1. This is our boundary data. Okay. And abnormal data, as you know, that anything that is not in this range between 1 and 5. Question 26. A program allowed the user to enter their age as whole number between 10 and 100 years. Inclusive. Give example of the following type of test data for this program: normal data, abnormal data, extreme data, and boundary data. So let's see. So the normal data for this program is any number between 10 and 100, inclusive, for example, 10, 20, 50, 100, etc. Then the normal data, any data that is not between 10 to 100, for example, 9, minus 1, 11, 200, age, 12.2, okay? Then extreme data, the largest number accepted is 100 and the smallest number accepted is 10. So this is our extreme data. Now let's see about the boundary data. So boundary data, either side of the largest bound, 100 and 101, and either side of the smallest bound, 9 and 10, is our boundary data for this program. Okay, question number 27. The program asks the user to input a number between 1 and 10 inclusive. Identify the test data for this program. I think this question is pretty easy for you. So let me quickly show you. So normal data is 1, 2, 3, 4, 5, 6, 6, 7, 8, 9, 10. Abnormal data is anything there less than 1 or greater than 10, or characters, string, example A, 2.5, minus 1, 8, 5. Okay, minus 8 and 5. Extreme data is 1 and 10. Okay, so 1 and 10. Okay, and then boundary data is 0, 1, 10, and 11. So this is our boundary data. Okay, now let's question number 28. A user need to enter a password that is at least 8 characters long. Provide an example of valid test data for this program. So for this program, the normal data is any set of 8 or more characters, but they must be text. Okay, have speech marks, for example. This is a valid data, and this is an example of valid data. Okay, because it's a 8-character long. Abnormal data, any set of characters with a 7 or less characters. 7 or less characters is our what? Abnormal data. Extreme data, any with 8 characters only. Okay, for example, this one is also our extreme data. Boundary data is what? Either side of 8-character, bound, 7-character, or 8 characters. Example, this one. This is all our boundary data for this program. Question 29, explain the purpose of using the test data in software development and testing. So test data is a set of values used to determine whether a solution is working as it should. Question 30, boundary data is one type of test data. Identify and describe 3 other types of test data. So we know that we have normal data, we have abnormal data, we have extreme data, and the last one is boundary data. Question 31, give the set of boundary data need to check that a whole number is less than 50. Okay, so what is the boundary data for this one? The boundary data is what? 49 inside the boundary and 50 outside the boundary. So this is our boundary data for this program. Next, tick one or more boxes in each row to identify whether each statement refers to variable and or constant. Okay, so let's talk about the variables and the constants. So first statement is you cannot change the values when the program is running. So that is what? Constant. It has an identifier. So both variables and constant have identifiers. So what does it mean by identifier? Identifiers mean names. Okay, so variables have name and constant as well has name. Next one, it is a memory location. So both variables and constant are memory locations. You can change its value when the program is running. So that is what is a variable. It stores a piece of data. So both variable and constant store a piece of data. Question 33, define the term algorithm. So what is algorithm? It's a series of steps that solve a problem. It's called the algorithm. Question 34, what are the 2 required elements for totaling program? Okay, so totaling program, first you need to have a variable called total and you have to initialize it to the 0. And second one is add the value to the total. So you have to add the values to the total and that's how you can. These are the 2 requirements for the totaling program. Next, what are the 2 required elements for a counting program? Okay, so first initialize the count variable to 0 and second one is add 1 to the variable for each item. So that's the requirement for the counting program. Question 36, a programmer writes a program to weight basket of fruits and guns, keeping the total of the weight and counting the number of basket. The total weight is stored in a variable called total and the number of basket is stored in a variable called basket count. Explain how the program can use these variables to calculate the total weight of the baskets and the total number of baskets. Include example of programming statement that would be used for totaling the weight and counting the basket. Okay, so totaling is what? Totaling is adding the weight of each basket to the total weight as each weight is entered. Then, hey, this is how you can do total equal to total plus weight. Then you have a counting, adding one to the number of basket as each weight is entered. So how you do the counting? So basket count equal to basket count plus 1. Question 37, explain the difference between the programming concept of counting and totaling. Include an example of programming statement for each concept in your explanation. So what is totaling? Totaling is used to sum a list of numbers. And here is example, total equal to total plus number. What is counting? Counting is used to find how many numbers or items there are in a list. And how you do the counting? Counter is equal to counter plus 1. Okay, so provide the pseudocode for the that perform the described task. First one is count control loop. So here is the pseudocode for the count control loop. For example, you start with the keyword 4, then you have a variable start, and then you have a keyword 2, and then you have the end value. And here you have the block of code that you want to execute. Then you have a keyword next, and then you add the start value here. So it will automatically increment the value each time that the program reaches here. Then you have a precondition loop. Precondition loop, so we know it's a while loop. So you start with the keyword while, then you have a condition, and then you have a keyword do, and then this is the block of code. You can add the lines of code that you want to execute, and it ends with the keyword end while. Then you have a post condition loop. Post condition loop is a repeat until loop. It starts with the keyword repeat, then you have a statements, and then you have a keyword until, and after the until you have a condition. Okay. Let's see the question number 39. Provide the pseudocode that perform the described task. So first one is totaling. So we know total. First, you need to create a variable total and set it to 0. And then total is equal to total plus number. Then counting. Counting, first set the value, the count variable to 0, and then count equal to count plus 1. Then average. So first set the average to 0, variable average to 0, and then average equal to total divided by count. So make sure when you're calculating the average, you need to have a total and also you need to have a count. Otherwise, you won't be able to calculate the average. Question 40, provide pseudocode that performs the described task. So first one is if else. So how you write the if else statement? So first you write the keyword if, then you have a condition, then you have a keyword then. And then there are statements that you want to execute. Then you have an else keyword, and then the statements that you want to execute. And you use the end if keyword to close the if block. Then the case of statement. So first you have a keyword case and case of, and then you have a variable. You have to specify a variable name or identifier, and the first value, second value, and otherwise. Otherwise is same as the else. Okay. And then you finally close the case statement with the keyword end case. Question 41, provide pseudocode that perform the described task. So first one is procedure. How do you create a procedure? So you use the keyword procedure, then you would give the procedure name, and then specify the parameters. And here you will add the lines of code that you want to execute. And finally, you can use the end procedure keyword to close the procedure. That function, so function is what you start with the keyword function, then you have a function name, and then the parameters. It will be multiple parameters here and here as well, and it could be no parameters. Okay. Then you need to specify the return data type. So return, you need to use the keyword return, and the data type could be integer, string, char, whatever you want. And then here you have a statement that you want to execute, that will be executed inside the function. And then remember, you have to add a return keyword here and specify what value you want to return from the function. Look here, in the procedure, we do not have any return statement because procedure does not return any value, but function returns a value. That's why you have to specify the return keyword and the value that you want to get back from the function. And then you finally close the function with the end function keyword. Question 42, identify the validation rule this algorithm uses. So this is algorithm input number. Okay, if the number is greater than 0 and number is less than 100, then output valid, else in output invalid. Okay, so it looks like a range check because we want a user to input a number between what greater than 0 and less than 100. Okay, next, identify the validation rule that this algorithm uses. So this algorithm is what is using a repeat loop, okay, and then asking the user to input a value and checking that repeating until the value is what not equal to null and the value is not equal to empty string. So this is a presence check, okay. Next, explain what is meant by the validation and verification. Give an example of each one. So validation is what is checking if the data is reasonable and meets a certain criteria. That's called the validation. So we have different types of validation. For example, we have a range check, length check, type check, check digit, etc. Then let's talk about the verification. Is checking if the data entered into the computer matches the original source. An example could be double entry and visual check. Question 45, take one box in each row to identify if the statement is about validation or verification. So statement number 1, a check where data is re-entered to make sure no errors have been introduced during the data entry. So that's the verification. Okay. An automatic check to make sure that the data entered has the correct number of characters. So that's the validation. A check to make sure the data entered is sensible. That's also validation. Question 46, a program checks that the data entered is between 1 and 100 inclusive. Identify one piece of normal, extreme, and erroneous data for the program and give a reason for each. So now you have to tell me those 3 types of data for this program. Okay, so first one is what normal data. So normal test data is what is left, for example, 50, allow any number between 1 and 100 inclusive. And the reason is what data that is within the range and should be accepted is the normal data. So 50 is within the range and also it should be accepted. Next one is an extreme test data. So the example is 101, reason the data at maximum or minimum end of the range and should be accepted. Last one is a little bit trickier because you're going to see this word erroneous test data. So this is the abnormal data. Okay, then you just change the name. So erroneous test data or abnormal test data. The test data example 300 allow anything that isn't between 1 and 100 inclusive, including other data types such as chars, string, etc. Reasons data outside the range that should be rejected. Question 47. The program can perform validation and verification checks when the data is entered. Identify two different types of validation checks and explain the purpose of each one. So first one is presence check, ensure the data has been entered into a field. Okay, and it's not empty, the field is not empty. Length check ensures the data is correct number of characters or digits. Then you have a range check. Range check ensures the data is within a specified upper and the lower limit. Then you have a type check. Type check ensures the data is of a certain data type like integer or text. Then you have a format check. This check ensures the data follows a specific pattern or structure. Question 48. Give the name of one verification check that can be performed on the data when it is entered into a program. So here you can see we can say double entry check, and we can also say the visual check. Question number 49. Describe the difference between the validation and verification in the context of data entry in computer program. So validation checks if the data is reasonable or in the correct format, while the verification checks if the data is accurate or matches the original source. Okay. Question number 50. Identify a suitable validation check for the email address. This is the email address, and describe how this validation check would be implemented. Ensure that the validation check you choose is appropriate for verifying the format of an email address. So here we can see first validation check name is length check. So used is what to this ensure that the email is not too short, which would likely to be invalid, and does not exceed the maximum allowable length for the email address. Okay. Yeah. So that's okay. So let's start with question 51. Identify a suitable validation check that could be used for each piece of normal test data, and describe how it would be used. Each validation check must be different, and the test data for entering an year. So what should be the test data? So first one is okay, so first one is the check that we can use for this one is the range check. So range check, this check ensures that the entered years fall within a specified range, such as between 1900 and 2021. Okay. Next one is identify a suitable value. Same question. Okay, so let's see this one. The test data for entering a name. Okay, so what is the test data for entering a name? So we can use a type check for this one. So check the type of the data entered in this case to make sure that no numbers are present. Next one is the programmer has also decided to validate the email address and the password. Describe the validation checks that could be used. So here we can say for the email, we can use the length check to check this check to ensure that the email address is not too short or too long. Format check, this check ensure that the email address follows standard format, for example, username@domainname.com. For the password, we can use the presence check, verifies that the password field is not left empty, and the length check, this check to ensure that the password meets a minimum length required for the security. Four description of validation checks are shown. Draw one line to link each description to the most appropriate check. Not all checks will be used. So first one, we have here you can see the names of the checks, for example, check digit, format check, length check, presence check, and type check. Okay. So to check that the data entered is an integer, so that's why we can use the type check. Okay. So to check that that some data has been entered, so that's the presence check. Then to check that the data entered has an appropriate number of characters, so we need to use the length check. And then to check that an identification number contain no error, so that's the format check. Question 55. Data entered by a customer includes the age of the driver. Identify two different validation checks that could be used for the age of the driver. Justify your choice for each validation check. Okay. So here you can see first check you can use as a presence check. Please then need to enter the age to calculate the price. And then you can use a type check. And the reason is verifies that the age enter is a numerical value, and preventing non-numerical inputs like letters or symbols that would not present a valid age. Then you can also use the range check. Reason is what? To ensure the age entered falls within a realistic range, such as 17 to 100, to confirm that the driver is of a legal driving age and not the excessively old. Question 56, trace the following algorithm using input values of 1 and 3. Provide the step-by-step output for each stage of the algorithm. So now you have an algorithm. You need to trace this algorithm using a trace table. So let's first create a trace table. How do we create a trace table? We first need to find all the variables in the code, and also we need to have a one column for the output. So we have a variable number 1 and number 2, and then there's no other variable. That's why we just add the one column for output. Okay, so let's start reading the code line by line. So first line says input number 1. So what is the value of number 1? It's given here in the question, so it's 1, right? Input number 2 value is what? 3. And then if the number 1 is greater than number 2, then output number 1. So if the number 1 is what? It's 1, then it's not greater than number 2, right? So we ignore this line. Let's go to the else output number 2. So we output the number 2. So we output the number 3 here. That's it. Very simple program. Okay. Trace the following algorithm using the input values 4, 3, 2, 1, and 0. Okay, so let's see. We first create the trace table. We need to find the variables. So we have a count variable, we have input value, we have total variable, and I think that's all. And then we can have one output column. Okay, so now let's start with the line. Let's start reading the line of code. First line says count is equal to 0. Okay, we input write the 0 here. Input value is equal to 1, total is what? 0, and there is no output. Now let's read the next line. While input value greater than 0, so input value is what? 1 is greater than 0 is true, the condition is true, then we go inside the loop. So first it says input value. So what is the first input value? Is 4, right? So we add 4 here. Then it says total equals to total plus input value. So total is what? 0, 0 plus input value 4. So 0 plus 4 is 4. And then count equal to count plus 1. So count is 0, 0 plus 1 is what? 1. And there is no output. So since we are in the loop, we go back. We again check our condition. So input value is greater than 0. So input value is 4 is greater than 0. The condition is true. We go inside the loop. Input value. So what is the input value? Next input value is 3. So we write 3 here. And then is what? Total equal to total plus input value. So what is total? Total is 4. Input value is 3. 3 plus 4 is 7. And then we add 1 to the count. Count is equal to count plus 1. Count is already 1. 1 plus 1 will become 2. And there is no output. Again, we go back, we check the condition. So input value is greater than 0. Input value is 3, right? The condition is true. We go inside the body of loop, input value. So input value is what? 2. Next value is 2. So we add 2, then total plus input value. So 7 plus 2 is 9. And count plus 1, count will become 3 and no output. Still, we are in the loop. We check the condition. Input value greater than 0. Input value is 2. It's greater than 0. The condition is true. We go inside the body of the loop. Input value. Next input value is what? 1. Okay, then input total is equal to total plus input value. Total is what? 10. 9. 9 plus 1 become 10. 10. And count equal to count plus 1. So 3 plus 1 is 4. And there is no output. So now we go back again. We check input value is greater than 0. Yes, it's true. Okay, we go inside input value. So what is the next input value? It's 0. So we write 0 here. And then we add what? Total equal to total plus input value. So what is total? Total is 10. 10 plus 0 is what? 10. And then a count is equal to count plus 1. So count is 4. 4 plus 1 is what? 5. And there is no output. Now we go back again, we check. So input value is greater than 0, input value is 0, and it's not greater than 0, so that's why the condition is false. So this time we do not run these lines of code. We come here, okay, output total is total. So what is output? Total is total. What is the value of total? Total is 10, so we can show a message, output total is 10. Then second line says output, there were count numbers. So count value is 5, so we can just simply output the message, there were 5 numbers. Okay. Let's see question number 58. Create a trace table for the following code. The input values are 80, 100, 30, 20, 50, and -1. So let's start the trace table. Okay, so first we create a trace table. Here's our trace table. Okay. So line number 1 says total equal to 0. So we add 0 here, count equal to 0. We add 0, mark equal to 0. We add 0, and there is no value for average and output. So we just leave them empty. Then we line number 4, it says mark not equal to -1. So what is the value of mark? Is 0. 0 is not equal to 1. So means this condition is true. We go inside the body of the while loop. So first says input mark. So what is the first value of input? Is 80, right? So we write 80 here. And then it says if mark is greater than 50, this condition is true. Mark is 80, 80 is greater than 50, this condition is true. We go inside the body of if loop, if, okay, and count equal to count plus 1. So what is count? Count is 0. Count 0 plus 1 will become what? 1. Okay, and the total equal to total plus mark. So total is 0. 0 plus mark is what? 80. And though no average and no output value so far. Then we are still in the while loop. We go back here again. We check mark not equal to -1. Mark is 80 is not equal to -1. So we can again get inside the body of the while loop. Input mark. Next input is what? 100. Okay, we write 100 here. Then we check if mark is greater than 50. Yes, it is true. We go count equal to count plus 1. So count will become 2. And total equal to total plus mark. So total 100 plus 80 will become 180. And there is no average in output so far. Again, we go back. We check mark not equal to -1 is true. We ask the next input mark. What is next input is 30, right? So 30, now we check again. If the mark is greater than 50, so mark is 30, is not greater than 50, so we'll ignore those two lines and we go back again here. We check mark not equal to -1. This condition is true. We ask the user to input a mark. So this time the user input mark 20. Okay. Then 20 is again not greater than 50. So we ignore those two lines again. And then we go back again here to check here. Mark not equal to -1. Yes, mark is 20, not equal to 1. We go ask a user to input a mark. So what is the next input value? Is 50. Okay. 50. So 50 is what? Mark is greater than 50. So no, mark is not greater than 50. Okay. It's same as 50. So we ignore those two lines and we go back again here. So now it's this time again we check mark not equal to -1. Yes, this condition is true. We ask the user to input mark. So this time user input -1. Okay. So -1. And then if mark is greater than -50, so -1 is not greater than 50. So what we do is ignore those two lines and we go out of the body of the this one loop. And now line number 11. Line number 11 says average equal to total divided by count. So what is the total? Total is 180. And what is the count? Count is 2. So 180 divided by 2 will become what? 90. Then output what? Output count, comma, average. So what is output here? And count is what? 2. And what is the average? Average is 90. So we just output 2, comma 90. Question 59. The flowchart below inputs the highest height of children who want to ride a roller coaster. Children under 1.2 meters are rejected. The ride starts when the 8 children have been accepted. Okay. Complete the trace table of the following input data. So these are the input data. So let's first create the trace table. So we have a variable reject. Okay, a rider reject. We have a variable height. And what else we have? We have, I think that's it. Those 3 variables. Okay, so let's start following the code in the trace table. So first, rider is equal to 0, right? Reject is equal to 0. And we ask the user to input the height. What is the first height value? Is 1.4. So we add 1.4 here. And then we check if is height less than 1.2, height is not less than 1.2, it's 1.4. Then we go here, rider equals to rider plus 1. So rider is what? Rider is 1, 0, 0 plus 1, it will become 1. And then we check rider equal to 8. Rider is not equal to 8, rider is 1. So it's no. We go back here again. We ask a user to input the next number. So next number is 1.3. 1.3 is not less than 1.2. We add 1 here under the riders with 1 plus 1 become 2. Okay. Then we same thing. We check this condition is also false. So we can go back here again, ask the user to input the next value. Next value is 1.1. Okay. So this time the height is less than 1.2, right? So what we do? In this case, we go this way. Reject equal to reject plus 1. So we add 1 here under the reject. So 0 plus 1 is 1. And then this goes back to the input. So input the next number. What is the next number? Next number is 1.3. So this time we add 1.3. 1.3 is greater than 1.2. And then we come here. We add rider equal to rider plus 1. So rider is 2. 2 plus 1 will become 3. Okay. And rider, then we check this condition, rider equal to 8. This condition is false. Okay, it's because the rider value is 3. Ask the user to input the next height value. So next height value is 1.0, which is again less than 1.2. So we go this way. We add rider equal to, reject equal to reject plus 1. So reject will become 2. And then we ask the next input value from the user. So next height, what is the next height? Next height is 1.5. 1.5 is greater than, 1.5 is what is greater than 1.2. We come here, add rider equal to rider plus 1. So rider is what? 3. 3 plus 1 will become what? 4. And then we check again, rider is equal to 8. No, we go back, we ask the next in a height value. So its next value is what? 1.2. We add it here. Then again, we check. So it's less than, okay, so no. And then we add 1 to the riders, will become 5. Okay, we again check this one is false or no. We can add next value, 1.3. 1.3 is height is less than 1.2. No, we add 1 to the riders. Okay, so rider will become 6. And then we can check this condition is still false. We can go back again. We ask the user to input the next height. Next height value is 1.4. Okay, this one. And then we can do what? We can check this one here. So is height is less than 1.2. No, we add 1 to the rider. So here is the rider. We add 1. So now the value of rider becomes 7. Still not satisfied. We go back again. We ask the user to input the next height value. So next height value is what? 1.3. So now we do what? We check this one. This condition is no. And then we add 1 to the rider value. So rider will become what? Rider will become 8. So here now we check the condition. Rider equal to 8. So yes, rider value is now 8. So we go this way. Okay, this way. We output a message ready to go. So we can output a message ready to go. And then we just simply end the program. Okay, question 60. Describe the purpose of the algorithm. So what is the purpose of this algorithm? So first of all, let's see how you can tell the purpose of an algorithm. Okay, so there are different ways to tell the purpose of an algorithm. So you can use a trace table, or you can just dry read the code. So let's use the trace table method. So first of all, you need to find the variables in the code. So first we have a variable 1, value 2, and value 3. And I think we don't have any other variables. So we just write those variables named in the column. So value 1, value 2, value 3, and then we need to make one column for the output. Okay. So in this program, we don't have any test values. So we can just use our own test values to test the program. Okay. So let's say use test values if not provided. So we don't have any test values. So let's use our own. So I'm using value 1. Let's input is what? 1. Value 2 is 2. Value 3 is what? 3. And there is no output. Now let's see here, value 1 greater than value 2 and value 1 greater than value 3, then we output value 1. Okay. Else if value 2 greater than value 1 and value 2 greater than value 3, then output value 2. Else output value 3, and then output is what? Value 1 plus value 2 plus value 3. So we know that its output is what? 3, because it's the largest one. And then we need to add those values together. 3 plus 2 plus 1 is 6. Okay. So then it says repeat the process with a different set of data until you find a pattern. So let's try test the program with some different test data. Okay, let's say this time we're using the value 10 for the value 1, 20 for the value 2, and 30 for the value 50 for the value 3. Okay, the same thing, we'll check those conditions, and we know the largest value among those 3 is 20, and then we add those values together. So will be what? 45. So now we got the idea what this algorithm is doing. So it's asking a user to input 3 numbers, it's finding which number is the largest number, and then it doing what is then it's outputting the largest number and also adding all those numbers together and giving us the sum of those 3 numbers. Okay, so here is the purpose of the algorithm. The algorithm asks the user to input 3 numbers. It compares those 3 numbers and outputs the largest number and the sum of 3 input numbers. Okay, so that's how you can find the purpose of an algorithm. Okay, next example 1, describe the purpose of the algorithm. Input values are 1, 150, 10, 33, 3, and 42. Okay, so let's see. So first, same thing, we need to create a trace table. How do we create a trace table? We need to find all the variables and list them in the table. So quantity has 1 column total, and then you have the value, and then you have a small variable, and then you also have no other variable, right? And then at the end, you will add in 1 column named output. So let's dry run the code. So first, quantity equal to 0, total equal to 0, value equal to 0, and small equal to 999. Okay, and there is no output. Okay, so then we have a loop while quantity is less than 5. So what is the quantity? Quantity is 0, quantity is less than 5. This condition is true. We ask a user to input a value. What is the first value? First value is what? 1. The first input value is 1. Then we have an if statement. If the value is greater than 10 and value is less than or equal to 100, then we run those codes. So value is greater than 10. No, value is less than or equal to 100. So the value is what? 1 is less than 100, and equal less than or equal to 100. So yes, it's true, but this is and this condition is false. We will not run these lines of code under in the if statement. Okay. So we go back again, okay, here again, because we in the while loop, we ask a user to input the next value. So next value is what? 100. Again, we check if the value is greater than 10. So yes, 100 is greater than 10, and value is what? Less than or equal to 100. So yes, it's equal to 100. So this condition is true now. Now we go inside the body of if statement. So the first line is quantity equal to quantity plus 1. So what is the quantity? Quantity is 0. 0 plus 1 will become 1. Total equal to total plus value. What is total? Total is 0. 0 plus value. 0 plus 100 is become 100. Okay. Then we see if value is less than small. So what is the small? Small is 999. So if value is less than small, this is true. We go inside, small will become value. Small is what? Small will become 100 now. We're still in the loop. We go back. We check if the quantity is less than 5. So quantity is what? Quantity is 1 is less than 5. We ask a user to input the next number. Next value is what? 50. Then again, we check if the value is greater than 10. This is true. If the value is less than 100, that's also less than or equal to 100. That's also true. So we go inside the body of the if statement. So the first line is quantity equal to quantity plus 1. So what is the quantity? Quantity is 1. Okay. 1 plus 1 will become 2. Total equal to total plus value. Total is what? Total is 100. 100 plus 50 will become what? 50. 150. Sorry. And then we check if the value is less than small. So value is what? 50. 50 is less than the variable small value, which is 100. So we replace the value of small variable with the new value, which 50. Okay. Still in the loop, we go back. We again check quantity is less than 5. Quantity is 2. 2 is less than 5. The condition is true. We go inside the body of the loop. Input value. Next input value is what? 10. Okay. So 10 we input here. 10. And then we check this condition if the value is greater than or equal to 10. So this condition is true. And the value is less than or equal to 100. This is also true. We go inside quantity equal to quantity plus 1. So quantity will become 3. Okay. And total equal to total plus value. So total will become 160. Okay. Then we check if the value is less than small. Okay. So value is what? Value is 50. Sorry, 10. 10 is less than 50. So we replace the small with the value. So we replace the small will become now what? 10. Still in the loop. So while quantity is less than 5, so quantity is yes, it's less than 5. Okay, so we ask a user to input a value. Next input is user input is 33. Okay, and then this condition is true. Quantity equal to quantity plus 1. Quantity will become what? 4. 4. And then we add the total equal to total plus value. So total is 160. 160 plus 33 is become 193. And then we check if the value is less than small. So value is 33 and this value of small is 10. So it's not less than small. So we ignore this line of code. We go back again. We again check quantity is less than 5. Yes, it's 4. 4 is less than 5. We ask a user to input the next value. Next value is what? Next value is 3. Okay. 3, and then we check this one. Value is greater than or equal to 10. No, it is not. So we ignore those lines of code. Okay. And we go back again here. Again, we check quantity is less than 5. Yes, quantity is still 4. And we ask a user to input the next value. Next value is 42. Okay. 42. And then value is greater than or equal to 10. Yes, it's true. Value is less than or equal to 100. Yes, it's also true. We go inside the body of if quantity equal to quantity plus 1, quantity will become 5, total equal to total plus value, 193 plus 42 will become 235. And then we check if the value is less than small, the value is what? 42, and the small is what? 10. So this condition is false. We ignore this line of code and we go back again to check if the quantity is less than 5. So now the value of the quantity is what? 5. It's not less than 5. So we ignore this line of code because the condition is false. Now we go outside of the body of the while loop. Okay, here. So output small equal to comma small. So what is the output message? Small equal to what? Small equal to 10. So we can output the message small equal to 10. And then we output another thing, total equal total divided by quantity. So what is the value of total? 235. What is the quantity? Quantity is 4. Quantity is 5. So we can just simply divide and we get the 47. So now we know the purpose of this algorithm. So what is the purpose of this algorithm? So first one is to the smallest number between 10 and 100 is inputted. Okay. The second one is the average of the numbers enter that are between 10 and 100. So that's the purpose of this algorithm. Okay, question 62. Identify and correct the error in the following program description. The program is supposed to take 5 numbers as input and output the total of all numbers input. And the inputs are what? 1, 2, 3, 4, 5. So we need to find and correct the errors in this code. Okay. So let's see how can we find the errors in this program. So we can use different methods. The first method is using the trace table. Okay, so let's use the trace table. So total equal to what? 1. Quantity equal to what? 1. Quantity is less than 5. If this condition is true, okay, we go ask user to input the first value. So what is the first number? First number is what? 1. Then total is equal to number. So what is total? Total is 1. 1 will become what? And no, sorry, we put the 1 number value into the total. So total will become 1, and quantity equal to quantity plus 1. So quantity will become 1 plus 1 will become 2. Okay, and there is no output. We stay in the loop. We go back again. We check quantity is less than 5. Yes, quantity is 2 is less than 5. We ask the user to input the second number. Second number is what? 2. And then we do what? We say total equal to number. So total is what? 1, 1, and we replace the number 1 with the value 2. This from here, and quantity equal to quantity plus 1. So what is the quantity? Quantity is 2. 2 plus 1 will become 3, and there is no output. Then again, still in the loop, we go back, check quantity is less than 5. Yes, is true. Input the number. Max input is 3. 3. And replace the value of total with the value of number, which will become 3, and add 1 to the quantity. Quantity will become 4, and no output. Still go back. Okay, we check the condition. Quantity is less than 5. Yes, is 4. Less than 5. Ask a user to input the next number. So next number input is what? 4. And then we replace the total variable with the value of number, which will become 4. And quantity is what? Quantity plus 1. So quantity will also become 4 plus 1, 5. We go back again. Now we check if the quantity is less than 5. The value of quantity is 5. It's not less than 5. Okay, so this time the condition is false. So we ignore those 3 lines, and we go outside of the loop, and then we run this line. So this line says output total. So output what? Total. Total is what? 4. So now can you tell me what is the mistake in this program? So read the description of the program, and can you guess the problem this program? So the problem is here. First problem is in this line. So the total, okay, should be what? 0. Next, the problem is here. It should be what? Also be 0. Next problem is here. It should have less than 6 or less than or equal to 5. Okay, because we need to accept what? 5 numbers. Next one, the problem is here. Total equal to number. So it should be total equal to total plus number. Okay, so let's continue with this program. So let's see what is the error. Okay, so first one is this one. So total equal to number. So the total start at 0, not at 1. So it should be total equal to 0. Second one is this one. While quantity is less than 5. Okay, so we need to change the condition to either quantity less than 6 or quantity is less than or equal to 5. Okay. Then total equals to number. So the variable total is overwritten each time. Convert the correct version would be the total equal to total plus number. Okay, so now same thing. We continue with this one, and then now let's fix the code. Okay, so first let's fix the first line. So total equal to 1. So we need to make it total equal to 0. Then while quantity less than 5, so we need to make it less than 6 or less than or equal to 5. Then we need to fix this line, total equal to number. So we need to make it total equal to total plus number. Okay, that is the correct version of the code. And that's how you can find the errors in the code. Okay, now let's see another method of finding the errors in the code. The following algorithm is designed to take 3 numbers as input and output output both largest value and average value. Identify the error in the code. So in this method, we just need to first find out what are the requirement of the program. Okay, so here we can see I have listed the requirements first. It asks a user to input 3 numbers. Then it find the largest number, output the largest number, find the average value, and output the average value. So these are the 5 requirements that we need this program to fulfill. Okay, so now let's analyze each task or each requirement one by one and see if which requirement is not completed. Okay, let's go to the next slide and see here. Okay, so first of all, the first requirement is ask a user to input, take 3 numbers as input. The program should take 3 numbers as input. So as we can see here, it is using the for loop and asking a user to input 3 numbers from 0 to 2. So this requirement is completed, no problem, this one. Let's see the next problem. Next problem is finding the largest number. So how do we find the largest number? So there are 2 sub-requirements for finding the largest number. First one is to initialize the largest variable with the low number. So we have a largest variable here, but it's not initialized with the lowest number. It is just missing the minus sign. So this is problem here, one problem here. Okay. Next problem is what? It should check if the data input is larger than the data in the large case. So is it checking if is it comparing the input data is larger than the largest variable? So let's see if is it checking or not. So it's not checking it here. Okay. This is the second problem. Third requirement, next requirement is what? Update the largest variable with the new value. So here it is completed. I think this is no problem here. So I think we found two problems with this part. Let's see the next part. Next part, output the largest number. So let's see, we have outputting the largest number. Yes, it is outputting the largest number. So this requirement is also fulfilled. Number 4, find the average. So how do we find the average? So it's total divided by count. So it's also correct here. Okay, need to have total. Okay, and yes, we have a total here. And then we have to do what? Divide the total by the count. And here we are dividing the total by the count, which is 3. So it's also fulfilled. Okay. Next one, output the average. So here you can see we are outputting the average. So this requirement is also fulfilled. So now we can say there are two problems here in this line number 2 and this line. Okay. So let's go to the next question. Identify and describe 3 basic data types. So what are the 3 basic data types? So we have integer. We stored a positive or negative whole number that can be used with mathematical operators, and then the real or positive or negative numbers in the fractional part that can be used with mathematical operators, and then Boolean, a variable or constant that can have only 2 values, true or false. Then you have a char, a single alphanumeric character, and a string, multiple alphanumeric characters. So these are the 5 different types of data types that we use. Question 68, write the pseudocode statement to perform the following string handling operation on the variable myString. So what is the first one? Find the length, convert to uppercase, convert to lowercase, and find the first character. So we have a variable name is myString, and we need to perform all those operations. So it's very straightforward. So first one, the first is what? Find length. Finding the length. So we use the length function, and we just specify the myString variable here, and it will convert it will give us the length of the myString variable. Then to convert to uppercase, we use the uCase function. Okay, to convert to lowercase, we use the lcase function, and to find the substring, we use the substring function where we specify the string and then the range that we want to extract. So 1, 1 will give you the first character from that string. So you need to know those functions: length function, uCase function, lcase function, and substring function. Okay. Question number 69, explain the difference between the program concept of sequence and selection. In your explanation, provide an example of a programming statement for each concept. So what is the sequence? Sequence is the concept of one statement being executed after another. Here's the example. For example, it will execute the first statement, then it will execute the next one. So in other words, a sequence means running the code line by line, or in the sequence that the sequence that we use it to write the code. Okay. Next one is the selection. Decides which statements are to be executed depending upon the result of a question. Okay. So here you can see, for example, you have a if. If is used as is considered as a selection statement because we first have a condition. If the condition is true, and based on the condition result, true or false, we execute the line. Of course, if this condition is true, we'll execute print X. If the condition is false, we execute print Y. Okay, give the pseudocode for the following types of statement: an assignment statement, a selection statement, and iteration statement. So for the assignment is simple X, and then you use the arrow, or you can also use the equal sign, and that you have a value, okay, that you want to assign to that variable. Then you have a selection statement. Selection statement is if or the case statement. So if X is greater than Y, you have this is the condition, then the keyword then print something else, print something, and is end with the keyword and if. Then you have iteration. So iteration is what? Well, it's a for loop or while loop or the repeat until loop. So it starts with the for X to 0, X equal to 0 to 39. So you specify the start value and end value. Then you have the lines of code that you want to execute, and finally it ends. Okay, so total equal to total plus input, and then input next X. Okay, so that's how you write the iteration statement. Okay. Okay, for each of the 4 groups of statements in the table, place a tick in the correct column to show whether it is an example of selection or repetition. So selection is what is, for example, if and case statement, and repetition is what while loop or for loop or the repeat until loop. So first one is a for a equal to 1 to 100 and b equal to b plus 1 next a. So that's of course is a repetition. It's because we're using a loop here, for loop here. Then you have a case of statement, that's a selection. Then if is a selection, repeat until is what is the repetition of the loop. Okay, give one example of a nested statement. So what is a nested statement? So a nested statement, a selection inside a selection. Okay, an iteration in an iteration, a selection in an iteration, or an iteration in a selection. So these are all examples of nested statements. Okay. Question 73. What will be this the pseudocode statement length? Hello, hello world return. So we know it's using the length function and it should return the length. So what is the length of this word? So let's count 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So this word count is what? 12. Okay. Why 12? Because we also need to count the space. Okay. And also this word. So let's see what is the output. Yeah, it's 12. So the length is what? 12 for this function. Okay. Question 74, take one box in each row to identify if the statement about subroutine is true or false. So first statement is what a subroutine is called from within the program. So that's true. A subroutine is not a complete program. That's true. A subroutine is a self-contained piece of code. That's true. A subroutine must return a value to the code from which it was called. So that is false because we have two types. We have two types of subroutine. One is called the procedure. Second one is called the function. Function only return the value, while this procedure does not return any value. Okay. What is the key difference between the procedure and a function? So a function returns a value while a procedure does not return any value. Write a procedure to take 3 number as parameters and output the largest. Okay, so let's see how you write the procedure. So we start the procedure with the keyword procedure. Then you have a name of a procedure, and then you have the parameters. Parameter 1, 2, 3. So this procedure is taking 3 numbers, right? So that's why we have to specify 3 parameters. And then simply we add the if statement inside the procedure, okay? And then we close the procedure with the end procedure keyword. Okay, you can pause and you can have a look how this is working. Okay, name one feature that help improve the code readability. Okay, so what is the feature? First one, use comments. Next, use meaningful identifiers. For example, use the meaningful variable names or function or procedure names, etc. And use the subroutine. Okay, subroutine will make the program more readable. Okay, explain the difference between a variable and an array. So a variable is a single storage location in the memory that holds a value, while an array is the collection of multiple values stored in a continuous memory location, allowing access to each value using an index. Okay, let's see the next question, question 79. Explain the meaning of the following terminology: array, array index, and array dimension and array index. Okay, what is array? Array, a data structure containing several elements of the same data type. That's important. Okay, they can only store the same data type. For example, you can only store integer, or you can only store string. Okay, these elements can be accessed using the same identifier name. Okay. Next one is array dimension. So dimension determined by how many index numbers are needed to locate a piece of data. For instance, one-dimensional array only needs one index number. Okay, so let's say student 0 will give you the first element in the one-dimensional array. A two-dimensional array needs 2 index numbers, and so on. Okay. Array index. Array index identifies the position of an element in an array. So index is what is an address of an element in the address in the array. Question 80, write a program to read 10 numbers from the user into a 1D array or one-dimensional array named my number. So how do we read the data from the array? So see, here's the code, for example, 4. We can use a for loop to do that one, for count 0 to 9, and this is the name of our array. And this is the index value. Here we're putting the index value as a count, and we're asking a user to input a number. So whenever user will input a number, it will store in the, for example, the first it will store in the index 0, then index 1 until index 9. Okay, and then we can just simply, this next count, we'll just add 1 to the value of the count. We're just starting from the 0. Okay, What are the three stages that need to be followed to write the data, to write the data to a file? So we want to write data to a file. So what are the three stages? First of all, you need to open a file. Second, write the data to the file. And third, close the file. Okay, remember those three stages. Open the file, write the data, and close the file. Second, what are the three stages that need to be followed to read data from the file? So now this time we need to read data from the file. So same thing, open the file, read the data to the file, and close the file. Okay. Next one, question 83, write a program to read in a value from file. File name is what? Data store.txt and output it. So how do we read the data from a file? First of all, you need to open the file, right? So we use the keyword open, and then we specify the name of the file. So let's say data store.txt, and then value equal to read data store.txt. So read function will read the data from the file txt and store it to the variable value. And then we finally need to close the file, and then we can output the value, output the variable value, and the value variable is storing the content of this file. Okay, write a program to ask the user to input a file name, then store the word house in the file. So first of all, we ask the user to input the file name. So user will input a file name, and we store that file name in a variable called the file name. Then we open the file name. Okay, so we use the keyword open, and then the file name is already stored here in this variable, so we specify it here. And then we use the write command, and inside the write, we just want to write the word house, right? So we just specify the word that we want to write with the file, and then simply you close the file with the close keyword. Okay, now let's talk about some question about the databases. Question 85, a shop that sells books has set up a new database table called book list to store books details. Part of this table is given what is the primary key field, how many fields and records are in the book table, what data types would you assign to each of the field in the book list table, choose the most appropriate data type. Okay, so let's first deal the first question. So what is the primary key? So this is the table, and you can see all the field names. So I think the most suitable primary key would be the category number. Okay, so it's a number of records. So number of records mean what? How many rows we have here? Okay, so 1, 2, 3, 4, 5. So we have 5 rows, which means the number of records are 5. Number of fields. How many number of fields? Number of fields mean how many columns we have in this table. So 1, 2, 3, 4, 5, 6, 7. So 7. What is the primary key? So it should be cat number, or category number should be the primary key. Next, we need to identify the most suitable data type for each column. So what is the first column is cat number. What should be the most suitable data type for this field? So you can see it's storing the data with alphabets and also the numbers. So this is alphanumeric data, right? So we can use the text for this one. Okay. Next, title could also be text. Fiction is storing the values yes and no, so it could be Boolean. Price is storing the value like 4.5, or it could be what? It could be real. Okay, question number 86. Write the SQL query to find the book by B. Penn in the book list table. So we have a table here, and in this table we need to find the books written by the author B. Penn. Okay, so what we need to do? What we need to select what? Select the title from the table. What is the table name? Table name is what? Table name is book list. Where author equals to B. Penn. Where author equals to B. Penn. Okay, so this is our query. Question 87, write the SQL query to show category and title of books that are only in the fiction genre from the book list table. Okay, so this time we need to show what? Show the category and the title of the book. So we have to show two things, category. So let's see, where is the category? Oh yeah, category number here, this one, and title. So select category number and title from the table. What? Table name is what? Book list. Where what? What genre of the is fiction. Okay, so fiction equal to what? Yes. Fiction equals to yes. Value in the fiction table equal to yes. Okay. A database table called TV range shows the main features and price of a range of televisions. What is the primary key field? How many fields are in the TV range table? So what is the number of fields in the table? So this time you can see we don't have the table. We just have the table field names and the description. So I suggest you, if you see this type of question, to make sure to read and understand the description of each field so you can use them in the query. So number of fields, so we know 1, 2, 3, 4, 5. So 5 fields. And the primary key could be the Storage ID, yeah, storage ID could be the primary key. So let's write the data type for each field. So what is the first field is what size in meters. So size in square meters, so we can say this could be the real because it's storing the size in square meters. Next one is position, first, second, and third. So it could be text. Okay. Then hoist, where there is the hoist available for the transfer of items. So hoist available or not available. So it could be Boolean. Okay. Price month, the price in the dollars for a month rental. So price and the scores are always stored in the real. So that's why we choose the real for this one. Now let's see the question 89. A storage unit rental company wants to set up a new database table for the storage unit that can be rented. The table is called storage units and needs to store these details. So these are the details, for example, size, meters, position, hoist, price month, and storage ID. Complete the structure query language SQL statement to display only the storage code, price, and size in square meters of all the storage units where there is hoist available. So now what you need to display, whatever you need to display, yes, you need to write it here. So display what? Display storage ID, price month, and size meter. Okay, so what we need to display here, display only the storage code. Storage code is what? Storage ID. Okay. And price is what? Price month. And size in size. So size is where? Size in meters. So these column from the table, what is the table name? Table name is what? Storage units. Okay, it's already given here. Where? So what is the clause? Where what? Where there is a hoist available. So hoist equal to what? Yes. Question 90. A database table called the TV range shows the main features and prices of a range of television. What is the primary key field? How many fields and the records are in the TV range table? So records, number of records, how many records? 1, 2, 3, 4, 5. 5 records, number of fields, 1, 2, 3, 4, 5, 6 fields. And a primary key could be what? Could be TV code, could be the primary key for this table. Okay. Now let's talk about the data types. So TV code could be text. We know this one. Screen size. Screen size is an integer, so we can just use int. Smart TV. Which is smart TV? Smart TV. Yes, no. So it's Boolean. Okay. Price. Always real. Okay. Okay. Next question. Complete the statement. Complete the structure query language SQL query to return the television code, screen size, and price of all smart TV in the TV range table. So select what? Select TV code, screen size, and the price from the table name TV range, where what? Where all the smart TVs, smart TV equals to yes. Very simple, right? Question 92. A company is storing details about their employees' salaries in a table called employees' salary. The table has the following fields. Okay, so these are the field: employees ID, name, department, and salary. Write an SQL query to calculate the total salary of all employees in the HR department. Okay, so we need to do what? Write a query to calculate the total salary. So we need to use calculate. So which function we use? We use the sum function. Okay, so select sum salary. Okay, from the table name, what is the table name? Table name is employee salary. Where what? Where department is equal to HR. Okay, so that's how you use the sum function. Okay, let's see one more example. Consider the following sales table that store the details about the product. So we have sale ID, product ID, quantity, sale date, and sale amount. Okay, so what is the primary key field? How many fields and records are in the sale table? Okay, so now first let's see the number of records. So 1, 2, 3, and 4. So 4 number of records. Fields 1, 2, 3, 4, 5. So 5. And primary key. So here's the tricky thing, right? So we have 2 columns. One is sale ID and second one is the product ID. Okay, so which table we would use for the as a primary key? So because the table is what? Is the sales table. That's why we use the sale ID as our primary key. Now let's find the data type for each field. So first one is the sale ID. We know for ID, the thing where we combine the numbers and alphabet, so it's always text. Okay, product ID is also what? Text. Sale date. So what is the data type? It should be date and time. Okay, and quantity is a whole number. That's why it's the integer. Question 94, display the product code and the sale amount of all products that were sold before January 10, 2025, ordered by the sale amount in the descending order. Okay, so this time we have to use the order by command. Okay, so select what? Select product ID and sale amount. From table name is what? Sales. Where sale date is less than this date. Okay, order by what? Order by the sale amount and descending. So order by this column and descending, DESC. Question 95. A database table. Museum is used to keep a record of items in the museum. The table has these fields: item code, description, in-store, century, and the country. Complete the query to display only the description and the country of the region or country of origin for those items not in the store. So you need to show what? You need to show display the description and the country of origin. So description and the country, right? Country here. So description, comma, country. From the table name is what? Museum. Where what? Where item not in the store. So in store equal to no or 0. Okay. Okay. Let's see the question 96. A database table nurse is used to keep a record of disposable item worn by the veterinary nurses. This is part of the table. So this is an item number, description, signage uses, and stock level and record level. Okay. So complete this query to display only the item number and description of single use item where the stock level is below the order level. Okay, so we have to have two clauses now because that's why we're using the and here. So select what? Select the item number and description from the table nurse where what? Where single use equal to 1 and the stock level is less than record level. I want you to pause the video and read this question again to understand because we're using the two conditions here. Okay, so if you have this type of questions, you do not miss the question. Okay. Question 97, a database table. Chocobar is used to keep a record of chocolate bars sold. Chocolate bars are categorized by this one: size, fill-in, price, and number sold. Complete the query to display only the price, filling, and the number sold of small chocolate bars that have sold fewer than 10 bars. Okay, so display what? Display only the price and filling. So display price, filling, and number sold. From the table, what is the table name? Chocobar is mentioned here, where what? Where size is small and number sold is less than 10. Okay. Question 98, data about planets in the solar system is stored in a database table called the planets. The fields used in the tables are shown here. Okay. Complete the query to output the planets with longer year length and greater mass than the Earth. Okay. Assume the Earth year length is 365 days. Display only the name of the planet stored in the alphanumerical order. So what we need to do? Select what? Select the planet name from the table planets where what? Where year length is greater than 365 and large is equal to yes. So large, this one is storing whether or not the planet has a greater mass than the Earth. Okay, that's why we're using it large here. So you have to read the description of all those columns, what it is storing. Otherwise, you won't be able to answer these questions. Then order by what? Order by the planet name ascending. ASC means for ascending order. Okay. Question 99, a computer game shop record its stock level in a database table called games. And the fields used in the stock table are shown. So these are the fields. Complete the query to output the games that have no stock and that are on order with the supplier. Display only the game ID, game name, and game price field in the alphabetical order of the names of the games. So select what? Select the game ID, game name, price from the table games where stock level is 0 and order equal to 1 or order equal to yes. Okay. Order by what? Order by the game name ascending order. Let's see the last question. Identify the 4 basic data types used in databases and provide an example for each one. So we have integer, a whole number without a decimal point, for example, 42. Then you have text, a sequence of characters used to represent text, for example, hello world. Okay. The date and time, a data type that will present a specific date and time, for example, date or sometime. Okay. A Boolean, a data type that can hold one or two values, true or false. Okay. One or two values. Real, a number that can have a fractional part used for precise calculation, for example, 3.14. And the last one is character, a single character often used for fixed length strings, for example, A or any symbol, but single one. Okay, so that's it.